Yeah, hi guys. So let's start with this question that is given to us. So we can see this that here we are given a ordinary doubly linked list, and what we need to do, we need to convert it into a memory efficient version of doubly linked list that is there. So how do you think we can do it? We can see here that we actually need to complete some functions which are insert and get list function that is there. Insert function will always try to do what? It will try to insert at the beginning, and get list function will try to return the linked list. So get list function is just finding out the entire linked list. Insert function is inserting at the beginning of the linked list. We can see this for memory conversion of a doubly linked list. What we need to do, we need to use here XOR operation that is given in this question. So if any two linked lists are given, or let's suppose their nodes are given as A and B, what we need to do, we need to do XOR of both of them and then try to store. So let's analyze the problem statement that is there with the help of example. We have already seen this, that in doubly linked list we try to do this. We have a node that is there, we have a previous value that is there, and we have the next value that is there. So this is the node that is coming up. Now if I want, like let's suppose that if I want to make it memory efficient, I'll take here the node part, and what I'll try to do, I'll try to store what is nxp, or we can say npx as well, as it is defined in this particular class. So what is this nxp standing for? It is standing for this particular part, that n stands for here next or the next node, p stands for the previous node that is given here, and we can see x stands for the XOR operation. So this npx value is nothing but the XOR of previous as well as the next one. We just have to do XOR of both of them. So I think this part looks simple to everyone. So let's try on to this thing, that how we can code it like for both these functions, and let's try to see the implementation details. So I have this particular example. So we can see as of now, let's focus on our insert function. We need to insert at the beginning. Initially we can see the head that is given to us is null. Correct, that the head is null. As of now there is no element present in the linked list. As soon as we get an element, let's suppose that I get an element here as 9. So what I'll do, I'll say this, that this element 9, it will be present in the linked list. What do you think will be the npx value of it? Like if I ask you, the previous node is null, the next node is null. If we do XOR also, then also the value will be null itself. So we can see as of now, when the first value is getting inserted, the linked list will look like this. It will just have 9 and the npx value will be null. As soon as next element is coming, let's suppose the next element is 5. So we can see this, that we will create a node as of now 5. Initially this value is null, but you can see that it should contain npx. Npx means the XOR of previous and the next node. As soon as a new node is coming, right, the next node is for sure as of now for this particular node. Or if I ask you that since it is getting inserted before the head, it is present always in the front part. Like if we try to move it, let's try to move or erase this particular part, we can say this, that what will happen, I'll say this, that this 5 node, it will be present here, and we can say that before node of it or the previous part of it, it will always be null. And we can say this, that the next part, what it will be not null. So if you calculate the npx, we can see one value is not null and the other value is always null. So what do you think we can do? I can see here this part, right? I can say that the npx value for this thing, it is actually XOR of what is the previous, which is always null, and the next node, which is the head of the linked list. So if I do a XOR part, right, it will give me just the head. So I can say that the new node that is coming up, that is coming in this part, the npx of that part, it will be what? It will be new node of npx. It will be pointing to the head node. I think this part makes sense, because every time the next node, it should be the new node that is coming up, the previous head that is coming up. So I think this makes sense. Now what we need to do, we can see this, that once you make this change, right, that for 9 the previous node is 5, one more thing will change, this pointer will change. Why? Because initially it is null. but now it should store the XOR of what is the value. Like we can see it will store the XOR of the previous value that is coming up and the next value that is coming up. So how can we update this part? We can update it in this way. We can see that head of npx, because this is actually where head is pointing to as of now, right? So this value needs to be updated. It will be what? It will be XOR of two things. What will be that? One will be the new node that is there, because that is the previous node. And what is the next node? The next node stored at this position will be head of npx. So we can write here head of npx part, and I can just move it as well. So you can see this, that this particular line we will be writing where? We will be writing in the next part, so that you can see here that previous node is getting updated correctly. Like this value needs to be updated. So it is the XOR of previous node that is there and the next node that is coming up. I think this makes sense to everyone. Now what do you think we can do? Like you can also do a dry run to understand it better. As soon as 4 value will be coming up, right? You will see this, that if I draw here, 4 value will be here. Initially the nxp value, it will be the head, because this will be the head node that will be there because it has been inserted at the front. Once we write nxp, like 4 of nxp as head, now what do you think we'll try to change? We'll try to change this particular point where head is pointing to, and it will be what? It will be new node and the next value that is there. So we will do XOR of what? We will do XOR of the new node that is coming up and head of nxp, which is the next node that is coming up, which is 9 here. So once we do this XOR, right, we see that this value will get updated, and we can see that this function at the end will change 4 to the head node. If first 3 elements we focus upon, till here 4 will be the head, right? I think this makes sense. Now in the printing part, what do you think we'll try to do? So let's try to see here in the printing part as well what thing can be done. So I'll just erase this and let's discuss the printing part. So we can see as of now every node what it is storing. Like if we talk about, like we have here, let's suppose 4 we have, and then we have some nxp value that is there, then we have 5 node, and then we have a 9 node that could be there. So if we have these 3 nodes that are coming up, now what do we think we'll try to take? We'll try to take it in this way, that first of all, like we know that every node is actually not storing this next pointers. These are nxp values that are there. So this could be any other value, right? As of now, for diagrammatic representation, I have shown in this way. So what do you think we can do? We know that, right? What is this value and how can we decode a next value from it? We know this is the XOR of previous next XOR. So what I do is, once I'm on any node, let's suppose that this is my temporary, or you can talk it about as that this is your current node. In order to find out this next node, right, what I'll try to do, I'll say that my next node, it will be XOR of two things. It will be XOR of previous node that I've taken. Initially the previous node, it will be what? It will be null. So I'll do XOR of previous node and I'll do XOR of current node that is there, correct? Once I do of like this particular part, you will see this, that what will be the answer that we'll be getting. We will be able to find out the new node, or you can say the next node that is there. And for future preference, like since we want to move this loop together, we can say current will be moving where? Current will be going to the nxt part, and we can see there will be one change that will be happening, that previous it will try to go where? Previous will become the current node. So if you try to dry run this particular part, you will be able to understand that what actually is happening here and why we are trying to do this operation. But you need to remember, right, in order to make it move forward, we are changing, like we are saying that current every time it will go forward, and this will be the new current that will be there. And same way, what I want, I'm moving it with the help of this nxt pointer that is there. And this previous node will also change. Initially it will be pointing to null, next time it will go to 4, next time it will go to 5. So that is why with the help of this line we will be able to move it, right? So I think this part makes sense. So let's try and go to the code part. Yeah guys, so let's try to code this particular part. We can see here that these are the normal functions that are given, which we can use here. Apart from that, let's try like what are more things that we could have. We can see this that first of all in this insert function, we need to insert at the beginning. So how we could have done it? We could have done it in this way. I could have created here a new node. So let's create a new node, node star new node, and I'll pass here data. So I'll say this that new node and I pass the data that is there. Once I've created the new node, what I'll try to do, I'll say this that this new node of nxt that is there, or we write here npx that is there, it will be equal to what? Initially, you can see that the nxp value, since previous node is null and next node will be the head node. So I'll point it to the head node. Now, since we are attaching a node before head, so head nxp will change. So I'll check here that if head is not null, because the first time head is coming up, you will see this that at that particular point head will be null. So we can see what will be the value, that head of nxp, it will be updated to what? It will be XOR of two things. And what are those two things? We can see the first XOR that will be coming up, it will be, let's write it down, it will be the new node that is there, which is the previous to it, and we can see the next node, it will be stored in head of nxp that is there. Once we write it, it will get updated, and this function will try to return the new head. And what do you think will be the new head? The new node will be the head that is there. So what I can say, I can write here new node. Now if I want to get the linked list, what we'll do is we'll try to have a vector of answer. So we can say vector int answer that is there. Once I've stored it, what I'll do, I'll try to return this answer as well. Now one more thing that we need to do, let's try it out. We can see we'll need some other variables as well to iterate in the linked list. I'll say this that I'll have one current variable which is pointing to head node. Now we'll try to have here struct node star, and then we can say we can have a previous value that is there. Same way, initially the previous value will be what? It will be null. I can take one more variable which is the next node, or we can take it inside a loop also, even that will work. We can say while current is not equal to null. This will help us just to iterate in the linked list. I know that I'll insert the answer into this answer vector, so I'll write here pushback, and I'll write here current of data. You can see here data value is defined, so I can write current of data. Now we can see what will happen, that what will this current value will be and what this previous value will be. So this current value for the next time, it will become as some other node. So let's write here struct node star, and we can write what is the next node, guys. Try to think of that. The next node, it will be XOR of two things. And what will be the XOR of? It will be XOR of the previous node that is there, and it will be the XOR of current node that is there. I think in the diagram part I wrote only current, but it will be actually previous and the next node. Next node for this current is current of nxp, right? So we will find out that now current will move to this nxt part, and we will see this previous, it will move to the current part. So first I should write this statement to actually work this correctly. We can see this that first we should update previous is equal to current, and now current will move to the nxt part. So I think this makes sense to everyone. Now let's try to write it down. Correct, I think this is working as expected. So let's try to submit it and see if it is passing all the test case. Yeah, so I think it is passing all the test case. So you can try it out yourself as well, and let's meet up in the next video.